record on this computer. Okay, so this graph shows us the number of whales remaining on the y-axis and time on the x-axis. And because this was a common pool resource, it meant that any time anybody caught a whale, there were less whales available for other people to catch. And in fact, this can give rise to something called the tragedy of the commons. The tragedy of the commons is a situation where everybody in some group is using a common pool resource more and faster than they should. I'm wondering if you guys think that actually happened here, though. One question is the word should. How do we even know what they should, quote unquote, take? How many whales should we have taken? You have any thoughts on that? Who's to say that what you did here isn't optimal? After all, there's no reason to let whales live in this simulation because, first of all, they're not really whales. You're not actually harming living whales. You were rewarded for points for every whale that you captured. So you can argue that at the end of the game, at the end of the experiment, it makes sense to have captured all the whales you could. So that part, maybe you guys did okay. But what about these two oceans? The red was I believe the red was Pacific and blue is Atlantic. Red was Pacific and blue was Atlantic. Can we say like, well, one ocean actually did better than the other? I mean, it looks like the red one did. Was it more efficient to do that? Let me ask that. Was it more efficient to preserve the more whales for a longer period of time? You guys have any opinions about that?
The way I was trying to do it, and I guess I was trying to be the big influencer last time, was get it to the point where I think the whales maxed out at 150, to the point where everyone in the group was taking a bunch when it maxed out at 150. So, and but it keep replenishing back up to 150 or whatever, close to that. And so it would be a perpetual replenishment, and everyone would just keep getting more and more points.
Okay,
that's what I was going. I mean, because there wasn't really real coordination. There was more us talking and saying we were going to do something, and then we were allowed to do something else. But I think for me, I guess the point of this was for you to show how the tragedy of the commons plays out, because we were talking last class about like the reason the commission didn't work in the real world was because two countries just said no.
Yeah.
The reason it didn't work in this scenario is because a couple people just like no. So yeah. I thought it was interesting.
But it still sort of worked. Don't you think it did better than if you had no treaty at all? If you had no treaty at all and everyone just was really thinking of themselves as much as they could, what would have happened to the whales? In just 2 rounds, the whales would have disappeared. Did anybody calculate that? And look at what would have happened?
I think it would have gone for probably.
Would have gone a third?
Probably, I'm not sure, because it would have been 50 the first round, and you would have taken 50 the next round, depending on what the replenishment rate was. Probably. Third.
Yeah. I've already saved your point, so I think it's okay for me to do this. What would have happened if everybody took 10 in the Atlantic, the first round? It would go all the way down to 37. How does that calculated? Because it's 100 minus 70, then increased by 25%. That's where the 7 comes from. That's where it's 37. The very next round, you could have exterminated whales. There could have been no whales in the Atlantic by the year 1910. And in fact, it's sort of in your individual incentive to do that, isn't it? Have you guys thought about it that way? There's something called a social dilemma where what's best for you is different than what's best for everybody in the group, in the society. Anytime that happens, it's called a social dilemma. The very most simple, basic example of this is called the prisoner's dilemma, but that's just one social dilemma out of many. This problem that I gave you with the common pool resource is a social dilemma where, yes, it's in your own personal interest to get as many whales as you can. But if everybody does that, you're in a heap of trouble. You would run out of whales after just two rounds. Whereas the other, you could imagine the other ocean doing very well for, 1, 2, 3, 4, 5, 6, 7. In the Pacific, they lasted 7 rounds. In the Atlantic, only 5. But yes, so there is something more efficient about lasting longer, isn't there? In this case, because the whales regenerate. I've built that into the game. Let's say there was no whale regeneration of this game. Then it frankly wouldn't matter, would it? Whether you got them all now or later, the total number of whales is the same. The only game that you're playing is how do you split up the pie of total whales? Ooh, whale pie, that sounds awful. But that's the only thing left in terms of your decision making would be who gets which whales. But I specifically gave you a problem where there was something more complicated, and that was by leaving the whales behind in the ocean, it can be more efficient, you can be more prosperous later because of the regeneration of the population of whales. And I think we can say that on average, the people in the Pacific Ocean, which is red, who, if you recall, had a strong leader in Philip. Philip was, at least I'll say you were a strong advocate for reducing your whale catches. They had one person who is sort of ignored that, and that was Gibran. But actually, even Gibran benefited greatly from Philip's suggestions. He did the best. He got more points than anyone in this game. You want to see like how many points he got? He got a ton of points. Where is he? Oh, 43. Well, still, that's a lot. Right? How is it that Gibran was so successful catching whales? Yes, he got 43 whales, but it wasn't because on his own he just was really good at catching whales. He also got lucky to be in the ocean that was trying to otherwise preserve the whales. And because of that, the rest of you people in the Pacific Ocean made some lasting conservation efforts that Gibran was able to capitalize off of. Whereas in the Atlantic, you still got a lot of stuff. Wait, this is not right here. Why did I put all these 10s? Oh, I know. This is what is wrong. Yeah. There you go. This is what happened. Here we go. Yeah, you can see. Actually, there isn't a huge difference between the average score of people in the two oceans, 152, 159. So it actually was higher in the Pacific Ocean, a little bit. But because Gibran sucked up a lot of that profit, it really seems like the rest of the people didn't get so much. But okay, so what are the economics I want you to know about this problem? And that is this definition of common pool resources and the tragedy of the commons. I might even want to give you one more example of it before we move on, even though I really want to play another game. I want to play another game. And then if it's okay, we could play this other game and then talk about that as well. And then give you the more formal examples of tragedy of the commons and externalities and what sort of remedies are possible to these situations. Is that okay? So I have one mathematical example of the tragedy of the commons I want to give you, but I'm going to wait and do that Thursday, I think. Because today I want to make sure there's enough time to do another exercise. Are you curious about who's winning overall? Can you see this? Yeah, Nick has the most points overall because he did extremely well in the insurance market game. But there's many people close behind. Here's some in the 90s. Charlotte, Dorian have 90s. Mihak is in the 90s. You guys could catch him if you want. Christina, 89.7, very close. Okay, so let's talk about a different type of social dilemma. Okay, I'm going to stop sharing so I can, it's like I'm looking at you now. I gave you this social dilemma, which is called tragedy of the commons for common pool resources. And it really is a tragedy because the reason it's called tragedy is because when left alone, people do things which ultimately are bad for everybody, which is to use up all the resources right away. I will say that neither of the two oceans did that. Neither ocean was everybody maximize whale catches at all times, because that's what the economic prediction would be. And you didn't do that. You managed to sort of, what's the word, temper the tragedy of the commons. So it wasn't such a huge tragedy. It was somewhere in between the full-on tragedy and the socially optimal outcome. So that's what happened in that game. There's another type of social dilemma that deals with externalities. You guys know what an externality is? In particular, let's talk about negative externalities. If you are somebody who produces something, and that by virtue of your production, you've created something which causes a cost on somebody else, somebody who's not at all involved with your transaction. You know, let's say you're a firm and you have a factory and you're building cars, and you know you're factoring in the cost of building a car and the price you can sell them for, and you choose the profit maximizing size of factory and workers in the factory and robots inside the factory. You make all of these calculations based purely on the profits that you can get from your factory. But what if there's some sort of negative externality that's being caused? Well, you as a person who lives on the earth, of course, will experience some of that cost, but very, very little. And therefore, it really won't be factored into your decision as a car manufacturer. But if you sum up the total effect on everybody on the earth, or maybe it's a neighborhood, maybe it's a local effect, it could be a global effect or a local effect. It's very possible that the optimal thing for you to do is not the same as the profit maximizing thing to do. In the same way that the whale profit maximizing thing to do would be catch as many whales as you can every round. But socially optimal, it would be to leave some whales behind so that the population can flourish. The same thing happens here. The same type of social dilemma can happen in terms of production and negative externalities of production. So I want to shift the lecture from that one to the other one. Why am I doing this? It's because we're going to have our debate on climate change in next week. 2 debates on climate change, one on the Green New Deal and one on cap and trade, which I wasn't really sure if I should choose cap and trade. I almost think it'd make more sense to talk about just a carbon tax rather than cap and trade. They're not very different. Maybe some of you are policy wonks. I'm getting a little bit too much glare here. Let me, there, that's better. I don't know, do any of you, have any of you thought a lot about climate change and what economics has to say about ways to slow down the effects of climate change? Anybody planning to do that as maybe part of their paper for the class? Maybe you have, maybe you haven't. But there are many suggestions out there. One of them is a carbon tax, which says across the board, anything that creates a carbon emission into the atmosphere should be taxed a fixed amount. It can actually be a tax and what's it called when you get money back? Rebate. Is it called a rebate or a subsidy? I don't know if you want to call it a rebate or a subsidy. But there are these proposals out here that are very, very popular among economists. Side note, I actually did sign a proposal that was in favor of carbon tax, but it's not because I think carbon taxes are so great and awesome and we should definitely do it. It's because I think it's better than not doing it. That if all else equal, your choices are do a carbon tax or don't. Um, it's probably better. The people who maybe don't like carbon taxes, they could say, well, it's not necessary. We don't need them. And then there's another group of people who say, well, it's not enough. If you put a carbon tax in place, it will just nudge the economy away from carbon emitting technologies towards green renewable technologies. But that's not enough. You actually need massive infrastructural changes like the Green New Deal suggests. And carbon tax is like putting a band-aid on a huge problem and it's not enough. Anyways, we should have this debate next week. We will. And by the way, cap and trade is like a carbon tax, except instead of a fixed amount you have to pay for your carbon emissions, like, let's say $1 per cubic ton of carbon you emit, instead of that being fixed, it would be, there are these permits that you can buy and sell and trade for the right to emit carbon. So it adds a little bit more of a market-based solution to what otherwise would be a very fixed carbon tax. You say, well, certain people may want, certain people may want to emit more than others, and those people can buy these permits more, and it'll sort of, the market will adjust the prices for the permits. And some economists believe this is a better way, less intrusive way of getting businesses to reduce their carbon emissions. When I say carbon, you guys know what I mean. I don't just mean pure elemental carbon. I don't know how much you guys know about climate science. Like I'm just an economist. Like, why should I have to learn about climate science? Well, you could argue it's important for humanity, but for teaching a class like this, I do think it matters. What is it that economists can even say about what we should do? There's a little bit of climate science that needs to be spoken about so that we can even say, what would an economic solution or intervention to this world be, to this economy? Okay, so when I say carbon, it really means in the form of some kind of gas, some kind of greenhouse gas, like carbon dioxide is a greenhouse gas. So is methane, which has carbon in it, CH4. And there are some other ones, but you can sort of lump them all together and just call them carbon. But we don't mean the carbon that's, inside your elemental pure carbon, like diamond. No, that's not what we're talking about. Okay, so I want to have an exercise where we explore this other form of social dilemma, which is the negative externality problem. What is the negative externality problem, and why is it a social dilemma? Well, it could be that everyone would be better off if they would just lower their production of whatever is causing the negative externality. But individually, they do not have an incentive to do it. They make more money by producing more of it and having cheaper ways of production, even if they're, let's just for simplicity, we'll say there's like dirty production and clean. And I think I want to call it like carbon and what do I call it? Renewable or green? I might just call it green. So I want you guys to think about, what would you do if you were either a country or a major business, a major sector inside the country, somebody with a lot of power to decide how things are going to be produced. And your choices are produce it in a cheaper way, but that emits some carbon into the atmosphere, or produce it in a cleaner, greener way, which doesn't emit. And I have to also include in this model some cost. Of course, if there's no cost of the carbon in the atmosphere, then who cares? Just don't do it. Or just do all of it. And I decided to make the cost of carbon something that is shared by everyone. Everyone equally pays this cost. and it's equal to, it's a function which increases according to the square of the carbon emissions, okay? So at low levels of, can you imagine like the function y equals x squared? You know, it starts out flat. The function close to zero, y equals x squared is a very flat function, but then the slope increases and increases more and increases more and more. That's how I want us to think about these effects of carbon emissions in terms of the cost that we will all pay. So actually, for low levels of carbon, there isn't much difference between, you know, this emission or this emission or this emission. If everybody has low levels of carbon, it actually makes sense to even produce a little bit more because it's not very costly. But for higher and higher levels, it becomes increasingly costly. The economic term for this is convex costs, because the slope is always increasing of the cost function. Okay, so let me show you the thing that I want to do, and that is, it's kind of complicated, but I think I can explain it. I think I can explain it to us, to everybody. If you stick with me, I can explain it to you. Although I've already been explaining it. And that is, you're a country, and let's see, should I just write your names down? Therefore, you know, I'm not going to make you, if for some reason you don't participate, if for some reason you don't want to participate, so just tell me. Otherwise, why can't I see participants? Here we go. Otherwise, I'll just write your names here, and you'll be, once again, I want to split us into two groups. The reason I want to split us into two groups is so that one person acting alone can't sort of ruin it for everybody. If you're one person acting alone, you can ruin it for just your group, but then the other group is going to succeed, and you may actually regret acting like a rogue who doesn't care about anyone but themselves. So I've learned this technique after years of teaching, that I should never put everyone in the same group, because all it takes is one person to be sort of unreasonable and selfish to ruin the entire game. I guessed wrong about how many groups there were people, but Tony, even though alphabetically you should be in the second half, you're going to be in the first. Okay, we have two groups of 8. So can you see the screen now? I have, so far, let me try to explain what I have. These numbers are going to be chosen by you. I've just, as I created this game, I wanted to fill it in with numbers just to give you guys a sense of what's happening. And I have here on the left a group that has, look what their numbers are. On average, they're 60. So this group on the left, on average, is choosing to produce more using the carbon production. And they can choose any number between 0 and 100 for this column B, this production. And everything else will be determined for them, just based on what they do in carbon production. And here's why. Whatever you don't use for your carbon production, the rest of it will go into what I call green. Green as in like environmentally friendly production. So, however, it's like half as effective. You guys might hate me for this. If you're like a very liberal, progressive person, you may be like, why did you make carbon production more efficient than green production? It's just to prove this point. It's to give you this individual incentive to produce with carbon. If I made carbon and green equally effective, then everyone would just choose all green for their own purposes. So I had to make it a true social dilemma, which is to say, individually, you actually will do better by choosing a higher carbon production. And whatever is left over you don't use for carbon will go towards your green. Okay, here is a very important column. Hope you guys are following me. Are you following me now? This is going to affect how you play the game. If you understand the game, you'll play it better. What goes here is the cost that everyone has to pay for the climate change. What is it equal to? It's equal to the average carbon production for your group. So for these 8 people, I just picked these numbers kind of arbitrarily, but I made them so that they averaged out to 60. This number, if you can see, is equal to 60 squared divided by 60. 60 squared divided by 60, of course, is 60. So everybody has to pay this cost of 60. What do these people in this group get? They get whatever they produce for B, plus whatever they produce in column C, minus the cost of D. That's their total. So 72 plus 14 is 86, minus 60 is 26. That's where this number comes from. And that's going to be your points that you earn in this class, okay? And for this exercise. And remember, Nick's winning. Nick isn't here. You guys could all gain on Nick right now if you work together. There could be a new leader in the classroom. But do you see how this formula works? You guys have any questions about how your payoff works? It's going to be equal to whatever you choose here in B plus whatever is left over, which goes into C. But remember, it's X divided by 2. It'll actually be half as effective. So what I mean by that is, like let's take Hala. Sorry, I'm picking on you, but if you went 100 carbon, you would have 0 left over for your green production. Whereas if you did 0 carbon, you wouldn't have 100, you only have 50, because whatever you have left over is divided by 2, okay? So you're choosing a number between 0 and 100. If you choose 0, that means there's 100 left over, but because it's green production, I've built into this game that green production is less efficient. You may disagree with that, but I think for this game, it's not terribly important. Okay, and let's go back to 80, just so we have this example of the average is exactly equal to 60. Now let's look at this country over here, and different countries, but their average is only 30. And you can see because their average is 30, their cost of climate change isn't 60 like it is over here. It's only 15. This is kind of where that convex cost comes into play, because if I take 30 squared divided by 60, it's only 15. I don't know what it is. 30 squared is 900. 900 divided by 60 is 15. So even though their carbon production here is double what it is here, their costs are quadrupled. You see that? This left group has double the carbon production, 60 instead of 30, but their carbon costs have quadrupled, 60 instead of 15. And as a result, if you kind of look at their average production, look, you can see that it's higher. Can you see? Like these numbers average, or they sum up to 160. These numbers sum up to 400. They had a better, more points. They earned more points. However, this is truly a social dilemma, because look at, like, compare Jack in this example to Dorian. Dorian's only getting 1 point for this game, because Dorian, if you're listening, obviously you had nothing to do with this. I just arbitrarily put your name here with this number, but you can see how Jack, who's doing 94, is doing much better than Dorian, who only chooses 22, and that's because carbon production is so much more efficient. He made 94 points here and 3 points here, as opposed to her only 22 and 39. So you have this individual incentive to produce more with the carbon. Same thing even over here. Even though this group was better on average, look at Joseph. Joseph was greedy and selfish. Who knows? No, he was self-interested. He was profit maximizing. No, actually, he would have chose 100 if he was profit maximizing. And let me just see what would happen if he chose 100. Bam, look at that. He would get 81 points. He would get 81 points from just one game if he had chosen 100.
That sounds good.
Yeah. So what I'm going to do is delete these numbers. Okay. And you guys are going to privately, oh, it doesn't like it because you're dividing by 0, but that's okay. Once we put numbers in there, it'll fix that. You guys are going to privately chat to me what you would like your carbon production to be, and I'll put it in. And that will essentially determine what points you get in this exercise. But before we do that, does anybody have any questions?
I just like, I had one just for like example, if everyone in my group chose 50, just chose to do nothing for carbon, like the whole group would just get 50 participation points. Is
This
that
one
how that
here,
works?
like, do you want to
Yeah.
see like zeros?
Yeah.
Okay. Where's their, yeah, here's your total points. They would all get 50.
So the whole group would just get 50.
The whole group would get 50 if you all choose 0. Now, what if you all choose 10? Do you want to look at that? You think it'll be better or worse?
I think, not sure.
It got better. Is that surprising to you? Did you think that all zeros would be the best thing, Philip?
No, because there's like, because carbon is more efficient. Like there has to be
Exactly.
a ratio that works better.
And remember, I said the cost of climate change is really small for low levels of carbon because it's this x squared function. That's why actually all zeros isn't the best. I mean, of course, if other people do 0, you like that because that ruins that. Look how, see, I'll make you Philip, here your score is almost 55. That's better than if they had chosen 10. So what I'm saying is you always want other people in your group to choose as low as possible. But you want what happened if Philip chose 100 here? You could get 97 points just from this one game. If everyone chose 0, but you chose 100. I don't think that's going to happen. But maybe this shows you that this is a complicated game. It's complicated because I've created these trade-offs that the carbon production is twice as efficient as green production, but the costs of climate change are shared among everyone, and they have convex costs, which means they start out being very low cost of carbon, and then as it grows, it gets higher and higher and higher, and then eventually it gets really bad. What happened if everyone chose 100? Do you want to see that? You don't even want to see that, I bet. Do you have any guess what would happen? You would all lose 66 points. You would all be like, man, I wish I hadn't come to class today. I lost 66 exercise points. But that's what happens if you all choose 100. Now, if some of you choose 100 and some of you choose 0, I'll make, I mean, I don't know. So that makes your average carbon production something seemingly reasonable. But man, the people who choose 100 are doing so much better than the people who choose 0. They're doing 50 points better. So all of this you need to take into consideration. It's not an easy problem. I'm sorry for having to ask you to do it, but I'm really trying to make a point here, and that is to demonstrate some of the economic considerations in a social dilemma of the negative externality problem. So if anybody is ready, if anybody has any questions, you can go ahead and chat me, you direct message me your answer, and I'll put them in.
Are we doing just one round of this game?
So, good question. We'll do one round, and I think there will be time after that. We'll do another round, maybe differently though. There may be
Okay.
something different that happens the second round. But for this round, it's just carbon production. I'm curious, has anybody actually done some math here to try to figure out, like, it's not an easy problem. You know how I said my first class was like all strict and this one's more chill? Actually, in the first class, this is the type of problem that we would be working on. How to maximize, more or less, it's like optimization problems where there are many variables going into the equation. So if you want to, take that class. It's Econ 403. All right, I've gotten answers from Jack, Peter, Anna, Jacob, Joseph, Gibran, Mihak, Matt, Philip, and Dorian, and Hala. I can just stop sharing while I'm I'll put them in as you give me your answers. I'll put them in, and then I'll share with you what I got once I get it. Oh, this is going to be weird. I can still do it though. Ah. Okay. This is not working so well. I'm gonna. It always works better if I just leave it maximized. I have the chat box right there. So I will do that. Oops. Actually, I should just share it. I'm going to share it. That's what makes it the easiest. After all. What? Oh, I need to maximize this. Screen share. All right. Has everyone sent me their levels? Ah. Maximize. Trying to maximize. I think everyone has. I think everyone has. If not, I will shame you into doing it in just a second. By the way, did anybody try to make an argument to everyone? I guess I would have seen, right? Can you send a message to everyone but the professor? Actually, don't know if that's possible. Maybe it is. So let's see what people did. I got my first response from Jack, and he chose 75. Ooh, not looking good for the left group. Already, you have you're having some potential for negative. Jack, by the way, if it was just you would, in this group, you would have lost 6 points by doing this with 75. So you better hope that other people in your group are going to lower this below 75. Otherwise, you are going to be negative. You're going to wish you hadn't come to class today. All right, Peter, you chose 36. A little bit more responsible to our environment. Okay. Anna chose 25. Okay. Peter's like, phew, he's not going to be negative, probably. Jacob gave a 64. Thank you, Jacob. Joseph gave, to the surprise of none, 100. Whew, the average of the right-hand side has skyrocketed to 68, which means as of right now, Peter, you would be losing points. You would be negative 9 points because of Joseph's carbon impact on you. Gibran, you gave 37. Okay. I think you guys are not going to be negative now. Yeah, possibly. Mihawk 45. Matt 33. Okay, I think you guys are going to be fine. You're down. Average is now 50. Yeah, you guys are all comfortably not going negative. But only because there's people who didn't go hog wild on the carbon production. Philip, you chose 60, which is interesting. That was exactly the thing that was when squared divided by 60 equals itself. Dorian, 60 deuce, 62. Hala, 40. Okay, the average is about the same here. 53 on the left, 51 on the right. Ooh, Tony will make a lot of people in his group happy. He only picked 18. Look how much lower your average carbon production is, because thanks to Tony. What a good guy. Charlotte, 30. She's also going to lower the average carbon there. Camilla is going to increase it though, 67. It went up to 47 was your average. Okay, so those are your final points on over here on the left-hand side. You all had to pay a climate change cost of 37.8, which is kind of high, but it's not devastating. And because everyone is earning points, no one's going negative, which was absolutely not guaranteed. It was very possible that you guys just obliterated yourselves with, anything above 70. You would have killed yourselves into losing points on average if you had averaged above 70, I think, approximately. Okay, Christina, sorry, you gave a 46. Guys, am I talking too much? Lauren, 40. You're going to lower the average. Okay, that's it. We are done. Is that everyone? Yeah, of course it's everyone. What do you guys think about what happened? Well, congratulations. Everybody gained points. No one lost any points. The big winner is Joseph. He got 58.96 points in this exercise. He's like Mr. Moneybags, the Monopoly guy with the. Does he have a monocle? I don't even know if he does. I don't think he does. I think that's part of the Mandela effect, that you think that the Monopoly guy has a monocle when he doesn't. Oh, look how happy Joseph is. Hey, you did well, man. 58.96. Props, respect. Wait, no, I sound
Makes
like
up for that performance last class.
it makes it. Oh yeah, you did poorly last class. So, okay, let's talk about what happened. How did you guys choose these numbers? Anybody want to say where you came up with your numbers? The range was pretty big. Tony went all the way down to 18, which means his green production was 41. He still got 18 plus 41 minus 37. He's still got 21 points in this class. I have to say though, if the costs were higher, you may have gone negative, but you didn't. So everyone earned at least 21 points and at most 58. Okay, but how did you come up with these numbers? Anybody want to just tell me what happened in your brain?
From my last game, I figured I had some reasonable. From the last game, I figured I had reasonable people in my group, so I thought it wouldn't hurt terribly if I went slightly above 50.
Yeah.
I went to 60.
Okay.
And I figured there'd be at least one person that would max out my group because that's.
What do you think the average was going to be? You think it was going to be around 50? Because it was.
I would say that's about almost dead on.
What did you think it'd be around 60?
Well, I figured there would be people that would keep it lower. I thought that's actually almost dead on where I thought it was going to be. I was thinking like maybe like 45, between 45 and 55.
Okay. Yeah, you know what, guys? This is great. This is what I wanted to happen. There's some differences in how you responded to the incentives of this game. This was a true social dilemma where individually you're better maximizing it, like doing as much as you can in carbon production. But of course, if everybody does that, the cost of climate change just grow and compound and go up by the square, and you could actually all lose money. It's a true dilemma, and it was resolved in different ways by different people. Let's talk about interventions of this game. What if you're a government here? What could you say or do that might actually help the people in the games? Do you have any ideas? Remember, I talked about some interventions at the beginning of the class. I talked about cap and trade, which is, okay, rather than saying you can produce as much as you want of carbon, you have to like buy permits and then trade them with people. What would happen there? Do you think Joseph would go all the way up to 100 in his carbon production if he had to buy permits to produce that much?
No.
Because every permit you bought would have to come from somebody else, and they don't want to give up their permits. I mean, they might sell it to you for a certain price, but I have to say, this game is not rich enough to show you the benefits of a cap and trade system. And the reason is because the payoffs are too simple. The payoffs are so simple that there really isn't any. There is no, the marginal benefit of carbon production is the same for everybody. It's like 1. Okay, so because of that, there really is no incentive for you to trade your carbon permits. And that's why we can't do a cap and trade system. But just so you know, a cap and trade system would be like, I would say, okay, everybody, Anna, Camilla, Charlotte, Dorian, Hala, Jack, Jacob, Tony, everyone in this group and everyone in the other group, you get to have, let's say 25 carbon permits, and you can do with them what you want. You can either use them to produce carbon, or you could sell them to the other people for whatever price you negotiate with the other people. And then they would have them and they could produce like all the way up to 50 and you all the way down to 0 if you wanted to make that trade. That's what the cap and trade system does. Of course, you also need a government to enforce this, to say, oh, you only had permits to produce up to 50, but you went up to 60. I'm going to penalize you for that. But that's what the cap and trade system is. And we'll debate that, hopefully, next week. If I have my debaters ready to go, that would be great. Ask me if you need help, like what should we be talking about in this debate. Okay. What about the carbon tax? Can we have that in this game? How would that work? How would the carbon tax work in this game? Any ideas?
Wouldn't it just make it more expensive to use carbon? So
Okay.
I don't
Would
know
that be
how-
a good, would that be a good thing or a bad thing?
I guess it depends on how the equation works out.
Okay, but what if I tell you how the equation works out? And I say a carbon tax in this game is literally a per unit tax on carbon. Every production of carbon every unit of carbon you produce, I'm going to tax you a fraction of it. And I'm going to take all of that money and give it back to you in the form of a carbon subsidy or a rebate. But you might say, well, that won't change anything, will it? If the rebate and the tax are just offset each other, excuse me, but they won't offset each other for everybody, because the people who have the highest carbon production are going to pay the highest carbon taxes. So let's look at this right group here. Joseph chose 100. So if there were a carbon tax, he would have to pay the most amount of money into this carbon tax pool. Then everybody will get to benefit from his carbon tax payments, because they will get, even someone like who's the lowest? Matt was the lowest here. Even though Matt had the lowest amount of carbon production, he paid the least amount of carbon tax. He gets an equal share of the carbon tax subsidy. That is how you might want to think of a carbon tax working here. That everyone benefits from the payments of the carbon tax, but only the people who have the highest level of carbon production are going to. I shouldn't say only. I should say the more carbon you produce, the more you pay. That's the point. Could that work here? Could that actually help everyone, make everyone better off? I mean, the answer is yes. The answer is yes. But it's worth it as an economist to think about how this is happening. What's the mechanism? What mechanism causes this to be an improvement? And I told you, I said I was in favor of a carbon tax in real life. And so I'm trying to defend my own stance a little bit. I realize this is not a very realistic game. I made it really simple. But why is it that a carbon tax could help here? It's because it's changes the social dilemma. It used to be that the dilemma was, well, individually, I want to just produce as much as I can, assuming that other people will keep the average low. I want to be like Joseph and choose 100. Well, if there's a carbon tax, it could actually be that the person who produced the most carbon is the worst if the carbon tax is high enough. Now, if you go too high, everyone, I won't let you go all the way to a 100% carbon tax. But I will let you guys choose what you want the carbon tax to be. So I have it prepared. Aren't you glad? I don't have to make this up. I've got it already. I'm gonna go this way. Here you go. So here is the same game. I know this looks really complicated, but you've played it. I think I can explain it to you. Sorry, I'm blowing up. It's Charlotte's fault, not Charlotte, the person in our class, but the city, North Carolina. All right. So this is the same game. It actually started with these same numbers as we had before. Actually, it looked like different numbers. But there's going to be a carbon tax. And the carbon tax is simply whatever the tax rate is. See down here, there's a tax rate. Here it's 0.6. Here it's 0.9. I can change it. I can make anything. I make it 0.1. That's an awfully low carbon tax, right? 0.1 is low. 0.9 is high. But each person is going to have to pay here 0.1 times whatever their carbon production is. The person who had 94, they have to pay 9.4. The person who only did 22, they only have to pay 2.2. And all of this money goes into a fund, which is then shared equally in the form of $6 to everybody else. The costs of climate change are exactly the same as they were in the last game. Okay? So the only difference between this game and last game is that we have added a carbon tax, which is based on this rate here, the carbon tax rate, which I will let you choose. Or I might serve as like a Supreme Court to say what's too high to be unconstitutional, something like that. But you will choose the carbon tax, and that will determine how much you pay into this system. How much you get out of the carbon dividend system will be equal, and it's also equal to however much is put in divided by the number of players. Okay? And it'll be separate for this group too. This group will do it, and this group. I need to preserve your names. You know who's playing. Let's make it the same groups. Unless you want to change groups. Does anybody like, I hate my group, I want to switch groups? This way now. Here we go. Now you can see your names. But I think I should, once again, I put these numbers in here. The reason I put these numbers in here, they're sort of arbitrary, but they show you like what's possible. And you know, here's a group with really high carbon taxes. And look, so Mihawk is somebody who, in this example, had very low carbon production. Christina had very high. And look, Mihawk had a higher point total than Christina. Why is it that even though Christina had more total production, she had 64 plus 18, whereas Mihawk only had 0 plus 50? The reason Mihawk is ending up with more than Christina in this example is because of this huge carbon tax. 90% is huge, right? 90% of the profits you're making, or maybe even revenues, who knows, 90% of what you generate from your carbon is being taxed away from you in the form of a carbon tax. And of course, you're getting a big dividend. Even Christina is getting a big dividend. And that's kind of why she's still positive. Christina is still positive in this example. It sort of mitigates some of the risk. But Mihawk's doing even better because she did all this green production, 50, and got this big carbon benefit, 50 plus 20.7, minus a relatively small cost of climate change because the carbon production in this group was 23, whereas over here it was a little bit higher. It was 60. So yeah, I'm guessing these scores are generally lower than these scores. Do you guys understand what's different now, how this game works? I want you to be able to see your names. I think I'm ready now to delete these numbers because they were placeholders and I want to get rid of them. What's happening here? Oh no. This should say divided by 0. Oh gosh. Oh, let me fix this real quick. I thought I had done a good job of error checking, but there we go. Actually want there to be an error because I haven't put the numbers in yet. Yeah, those are ends. Sorry, just a little Excel or Google Sheet error, but I fixed it.
I had a question.
Go ahead.
How will our points be calculated between the two games? Is it
I'll
going to be
add them together.
Both games? Okay.
Yes, I will add your points from this game with the last game.
So
Maybe I'll make this one more important. I don't know.
at this point, is the tax rate unknown?
The tax rate will be determined by you, by
Okay.
the Congress. The Congress will be made up of you. So you can form some sort of government and tell me what the tax rate is, or you could vote by referendum. Everyone can tell me what tax rate they want it to be, and I'll just choose the median. How about that? Or does someone want to volunteer to be essentially like a leader of their group and then try to gain the support of enough people, a majority? If you can get the majority of people to agree with you on a certain tax rate, I'll just immediately make that the tax rate. If we can't get a majority of people to agree with you, that would be 5 out of 8. If you can't get 5 out of 8 people to agree with you, then I'll just say, okay, fine, everybody who cares, submit what tax rate you want it to be, and I'll choose the median of the tax rates. I actually believe the way things are decided in Congress is pretty similar to that. If someone has a majority, they just make it happen. If there's not a majority, then there's this compromise where whoever's in the median gets what they want. So use the chat. Will we pick the carbon tax before or after the carbon production? Great question, Dorian. The answer is before. So you choose the carbon tax before, and that will influence excuse me, the carbon production, right? We just saw what it was like with the 0%. You just played this game with the 0% carbon tax. And what happened? The average carbon production was 47 in one group and 49 in the other, which is kind of high, honestly, because you had your costs of climate change were 37.1 and 41. I mean, you perhaps could have done better by choosing a higher tax rate. What you could do is influence people's decisions and try to get them to lower their carbon production because of it. So you get to be like mechanism designers now. You get to think about as a policymaker, what sort of incentives do I want to give to the people who are then going to make their decisions to achieve a goal that I think is the best goal that I want to achieve. Philip wants to go 90%. Jack says 30. Tony says 37. Remember, if anytime I get a group of people who have a majority, then I'll just go with that. You can speak as well. You can unmute yourself. I mean, assuming it doesn't get too chaotic. If we have some leaders who want to speak, they can speak. I want to pick a maximum. I believe I saw what you wrote, Philip, as 90. I feel like as the Supreme Court, I'm going to say that's unconstitutional. That's too high.
Oh, come on.
You're infringing upon the liberties of the workers of the firms. I'm going to say 75% is the maximum. That's pretty high too. Come on, let's be honest. 75%.
Well, my theory is going with the higher makes people less likely to choose. Like going with a higher carbon tax makes people much less likely to choose a really high
Could be
carbon production.
Could be.
Which
Also,
is why I'm thinking I'm trying to make it higher the better, because I feel like the socially optimal outcome will be better if we have a higher, in this game specifically, if we have a higher carbon tax.
Remember though, everyone choosing 0 carbon production is not efficient.
I'm not saying 0.
I'm not one of these environmentally like hippie guys who thinks we need to completely get rid of anything that produces carbon. On the contrary, I've created a game where carbon production is more efficient and the costs of producing things with carbon are actually very small if the level of carbon is low. So choosing 0 carbon is actually dumb. You shouldn't do that. I'll just tell you right now. I mean, because it's so much more efficient to have carbon production. I mean, maybe you want to do it to help other people who, you're basically helping other people by lowering the average carbon production, but individually, there really is no incentive to go too close to 0, because like I showed you the example, everyone chooses 10, that's better for everybody than if everyone chooses 0. All right, so what do we got? What are some leading, I will help you guys decide. Philip,
you said so 90 is unconstitutional.
90 is too high, but I'll say 75 is the maximum. There's no minimum. You can go all the way down to 0 if you want.
I can get like the people on the other end to agree to that. What about other people, everyone else in my group, what about like a 60? It would still prevent people from like trying to go obscenely high and like mess up the rest of us, but it would also like give you some like room if you want to do more carbon production.
Yeah. Everybody who wants a very low tax, you do realize that you get the dividend back. So on average, the government is not keeping any of the money from the carbon tax. Everything that's brought in with the carbon tax is being given straight back out in the form of a carbon dividend. So it's revenue neutral. That's what they say, revenue neutral. So if your carbon tax is too low, it has the chance of doing nothing. And it's kind of like you're not risking that much, because of course you're risking. If you're somebody like Joseph and you want to do 100 again, get away with it again, then you want the carbon taxes to be as low as possible. Because you know you're going to get away with it again. I'm just saying.
Explains why I put 5 down.
Okay, Charlotte,
Yeah.
you say Charlotte's
Hey,
group has a
Joseph,
majority
if
for
you want-
30?
Are you,
Thank you.
if you want,
Thank you,
would
Charlotte.
you be okay with 55 instead of 50?
You might want to go above 50. Philip wants 50.
I'm
Yeah.
saying, like, would you be okay with 55? I guess in between my 60 and 50.
55, anyone? Why do you want 50, Mihawk? Fifty's fine. You want to do?
All right, well, that's 250s.
You guys should do 78%. JK. 75 is the max. But wait a second. When you guys know the carbon dividend only goes back to your group. I'm not going to give it to the other group. Did you know that? I think we're getting 50% as a
Yeah.
sorry, Philip, I know you want it to be higher than that, but I think we got a majority of people who want it to be 50.
Well, that's higher than the 30s I was seeing. And
Yeah. So right. So we have a little bit of an
that's
experiment
comparable.
now that one group with a 30% carbon tax, one with a 50%. You can see what happens here. Obviously, I can say the incentives are stronger in this right group to not cheat, to not give a really high carbon production and hope other people will give low ones. There's more of an incentive on the left than there is on the right. But it looks like we are ready to go. Now that we have our carbon tax rates, set, go ahead and send me when you're ready. But of course, think about it. There's a lot to think about here. If you're good at math, do some math. I'm okay with that. Take a minute or two. Just take a few minutes and do some math and figure out like what might be the best thing for you to do. I'm curious, is everyone who's playing ignoring the effect that they have on their own carbon costs? Because they're just one of 8 people. So it might be tempting to just sort of ignore whatever effect you have on the climate change costs, carbon costs. You might just say, I'll forget about that. Or maybe if you're thinking about it, you're like, wait, it's 1/8. I can affect that average by 1/8. Maybe I should think about that as well. Okay, I've got a lot of answers. I've got Gibran, Dorian, Joseph, Jack, Jacob, Peter, Anna. 1, 2, 3, 4, 5, 6, 7, 8. 8 people have given me answers out of. What are you doing, Philip? You give me a percentage. Is that for your tax? What is that?
Sorry, I meant to say, I don't know why the percentage. I meant to say the just the number.
Okay, that's your carbon production level. Okay. Is it all right if I just start putting it in? Everyone who is still deciding, I really don't like that you're going to get to see. But for some reason, it's like the best way for me to do it is by sharing the thing that I'm inputting your scores on is the best way for me to do it.
Could you just take us away from the screen so we can't see how we're affecting it?
How?
Like unshare the screen and start putting this stuff in.
That's when I
can't
can't. That's when I can't do it because I can't see the little chat box. I want to be able to. I want to see the chat box and the thing at the same time. Oh well, it doesn't matter. I think I'm getting everyone. I'm getting everyone's answer now. All right, thanks guys. I'm gonna start putting it in. Please send it to me if you haven't, but I think everyone has. All right, let's start with Gibran. I think Gibran has seen the error of his ways last time. He really chose the individually optimal thing to do, but in this game, I don't think he did. He's a new man. 25 for Gibran, 54 for Dorian, 80 for Joseph, to the surprise of none. Jack, 60. Okay, what do we look so far? The average is 57 on the left and 52 on the right. Not much difference. Jacob, 58. Peter, 20. All right, now it's getting lower on this side. Anna, 40. Philip, 30. All right, so I can see a difference already. The right side is averaging 38 and the left side 53. Could have something to do with the taxes. Charlotte went up to 70. I don't think she's going to be hurt by that. Hala, 50. Camilla, 55. Matt, 38. Yep, lower on this side. Mihawk, 40. Yep, lower on the right side. Lauren, 30. You guys knew you're going to be taxed more, so you chose lower carbon productions. Tony, 40. Tony always gives a low number. And Christina, 46. All right, we are done. Let's see what happened. On this side, on the left side, we had an average of 53.3. On the right side, pretty big difference. We had a 38.6. And remember, the cost of climate change increased with the square. So over here, it was, you paid a cost of 24.86. Over here, you paid a cost of 47. It's a difference of 23 points. You had to pay 23 more points on the left side than you do on the right side. Are you sure it was worth it to have the low tax rate of 0.3? By having the tax rate of 0.5, they lowered their carbon production to 38.6. It was probably wise.
What was the probability of all of us on this side, on my side, ending up with the same points?
The probability of that occurring is 100%. And the reason is because you chose a tax rate of 50%. So mathematically, if you choose a rate of 50%, that means everyone is guaranteed to get the same number of points. Now, the number of points you get actually depends on what, like, let's say Joseph, instead of 80, had chosen 0, right? You all would have done better, including Joseph, right? But you didn't, Joseph, you chose 80. Because your tax rate is 50%, it's this weird situation where that exactly offsets the benefit of the carbon. Remember I said carbon was twice as efficient as green? Well, because your tax rate is exactly 1/2, that doubling of your efficiency is cut by 1/2 and it's exactly equally efficient. However much you put in carbon or green is totally the same. It doesn't even, it doesn't change your payoff. Now what does matter is the total cost of climate change, and you want that to be as low as possible. But you didn't do that. Actually, you don't want it to be as low as possible, do you? There's a certain level I think you want it to be. Anyways, congratulations, everyone on the right gets exactly 44 points. But the reason that's not always true. It's only true because you chose a tax rate of 50%. Okay. How about over here? Nobody on the left got anywhere close to 44 points. They chose a low tax rate. They had a higher rate of carbon production. And because their tax rate was less than 50%, that means anybody who had more carbon production did better. The best one was Charlotte with 70. She got 32. The worst was Tony and Anna with 40. They only got 26. So here's how the carbon tax works. Now that we've played it, I want to tell you. At 50%, it means everybody gets the same payoff regardless. Above 50%, it means the people who have more green technology do better off. Below 50%, it means anybody with more carbon production does better off. I wanted to let you just choose what you wanted, and that's what you chose. I do think in both groups, your carbon production as a group was still too high. I said it shouldn't be 0, but 38 was a little bit too high. But we still, I still think we demonstrated what I wanted to demonstrate. Does everyone see what happened in the sense of how the carbon tax, did the carbon tax work? Compare this to last game. Okay. 47, 49. actually, carbon production went up. This tax rate of 30%, it did not lower your carbon tax at all. I think there was another effect going on, don't you? I think there was another effect, was that we were playing it for the second time. You knew it was the last time we were going to play, and you sort of went for it with higher levels of production. It was still a good exercise. At least I enjoyed it. I don't know. Do you guys have any final thoughts? Thursday we're going to recap this and give you some more concrete math examples of these two types of social dilemmas: the negative externality problem and the tragedy of the commons problem. And then we'll talk more about carbon taxes, stuff like that. But this was fun. Thank you. Thanks for playing, guys. I appreciate
Good
it.
question.
Sure.
So with me getting over 100 points, I'm basically being rewarded for polluting the environment.
Yes. In this
Got it.
game, yes.
All right, thank you. Have a great day.
Yeah.
Bye. Thank you.
Hey, you're producing stuff, and people are buying that stuff, right? I'm an
Yeah.
economist. We're like, yeah, let's grow the economy by producing more. Carbon production produces more. Sure, it causes these costs, but oh well.
Did you have just off the top of your head, what would be the thing that would maximize everyone's like total points? Like what number to put in would that be?
Yeah, you know what? I spent some time thinking about it. I think it's around in the 20s. If you somehow got your carbon, so it actually doesn't matter what the carbon tax is in some sense. If everyone produces the same level, it doesn't matter what the carbon tax is. The carbon tax is only a way to punish people who give a lot and reward people who don't, or punish people who produce a lot and reward people who don't. And like I said, if it's above 50%, it'll do that so much that it's better to produce low. If it's less than 50%, it doesn't punish you enough. So you could still improve yourself by producing high. But in equilibrium, where everybody's doing the same thing, the carbon tax does nothing. And because it just gives you right back the money that you paid. So yeah, there's a little bit of math to be done here. And I actually haven't done it to figure out what the truly optimal level is. Maybe we could figure it out right now, but I'm sorry, I haven't calculated that. You got to use that squared function that I had, c squared over 60. The carbon squared over 60. And then your benefit was c plus 100 minus c over 2. Yeah. But so if you're thinking about what's socially optimal, you actually need to add up everybody's carbon. And that's a little tricky. Okay. I think actually I can stop recording now.